We are looking at chapter number 3, which is motion in a straight line. Kinematic equations for freely falling body. Earth has its own gravitational pull, which is known as Earth gravitation force, and we know it as acceleration due to gravity. This acceleration due to gravity is always, if the object is like this, it acts downwards. This is actually at the center of the earth. So anything is pulled by the center of the earth. If you neglect the air resistance, the object can be said to be in free fall. And if the height through which the object fall is small, is very small compared to the earth radius, you can easily take g as 9.8 meter per second square. So this free fall is a case of motion with uniform acceleration, and this is the uniform acceleration. Now just consider the upward direction along y-axis, like this, y-axis. So just put a equal to, because the direction is this, acceleration is on the other side, means opposite direction. So a has to be minus g, that is a equal to minus g. Let us put it in the equation. We know v equal to v0, and when we put a equal to minus g, it will be v equal to v0 minus gt. Again, y equal to v0t minus half gt square. Then we have v square minus v0 square equal to minus 2gy. If we talk about free fall, the initial velocity will be 0, because if you are say you are on a tower, you are throwing something, and the initial velocity is 0, then of course it is going to get some velocity, some acceleration because of gravity. So it is always convenient to choose the vertically downward as the y-axis. So this as y-axis and upward as negative. So this as negative and this as positive. Then we get a equal to g. We don't have to put a equal to minus g then. And for a free fall, the yt, vt, at, that is distance time, velocity time and acceleration time graph are like this. First is the yt graph. This is the y direction, as I said. This is the time, and something is falling freely. So the distance is increasing, but in the negative direction along with the time. In this case, there is this was the free fall a yt graph. Now, because the acceleration, we know that v by t or dv by dt is nothing but acceleration, and since it is common always 9.8, so we have a straight line like this. And how about the acceleration? Acceleration is always 9.8 meter per second square. So the AT graph will always show you a straight line which is parallel to your time axis. An object is thrown in vertically upward direction, that means in this direction. We have to calculate the time to reach maximum height, that is this height we have to find out, and the maximum height. We know that we have some initial velocity by which we will send, so we say it as v0, right? And at highest point, this v, it will be 0, because after this it will momentarily be on rest or 0 velocity, and then it comes back to us. So the upward direction we consider it as positive, then v0 will be positive, and if this is positive, then acceleration has to be negative, and we know that the maximum height will be reached at v equal to 0. So v equal to v0 plus at. Let us put all these values which we defined. 0 equal to v0 minus gt, t becomes v0 by g. So as we have got the time, the maximum height, let us take it as h. Now put y equal to h, t we just found out to be v0 by g, and acceleration as minus g. Now let us put this in the motion equation. Y equal to v0 t plus half at square. We get h equal to v0 square by 2g. A stone, after having fallen from rest under the influence of gravity for 6 seconds, crashes through a horizontal glass plate, thereby losing 2/3 of its velocity. So only 1/3 velocity will remain. If it then reaches the ground in 2 seconds, find the height of the plate above the ground. So what is there? The velocity v of the stone, if it is striking the glass plate, so just velocity just before it is striking, if we take it as v, then this initial velocity, because the stone is at rest while it is being thrown, so initial velocity is 0 and final velocity we assume to be v, because acceleration is always at 9.8 meter per second square on this direction, time is 6 seconds. So let us put this value in this first equation of motion. We get velocity equal to minus 58.8. Now it is being said that it loses 2 by 3 velocity. That means it retains only 1 by 3rd velocity. So what is the initial velocity for the second case? That means after striking it, means after the strike is over, v0 is just 1 by 3rd of v, 1 by 3rd, say 1 by 3rd. This is 1, this is 1 by 3rd. So minus 58.8 is the velocity. What is 1 by 3rd of this? Minus 19.6. Now let us apply the equation again. The height of the glass plate above the ground, that means it is being thrown like this. So this is the glass plate. After this it reduces 2 by 3 and then is going to come back or wherever it goes. So h equal to v0t plus half gt square. v0 we just found out to be 1/3 of this velocity. The time is 2 seconds as given in the question. Gravity will always be on this side. But h equal to minus h. Why? Because the height is in the opposite direction. So minus h, if we take minus as this one, height has to be taken also in negative. So let us put this all in this equation. We get h equal to 58.8 meter. A coin is dropped from a balloon going up with a uniform velocity of 12 meter per second. So there is a balloon. It is going up in with a uniform velocity. Now this coin is being dropped from this balloon. If the balloon was 81 meter high when the coin was dropped, so when the coin was dropped, it was 81 meter high from the ground. Find the height when the coin hits the ground. So coin, when it hits the ground here, we have to find the time. We have to take g equal to 10 meter per second square. So at initial point t equal to 0, the coin is inside a balloon. So what will be the velocity of coin? Initial velocity is the same as what is the velocity of balloon. So after that it moved as a freely falling body. So we take upward direction as positive. Y is minus 81 because if this is positive, the y is going to be minus 81. Initial velocity is similar to the balloon, so 12 meter per second. And since velocity is going up, the negative direction will be for acceleration. So acceleration is g, that is minus 10 meter per second square. We apply the law of motion and we put all this value, we get a quadratic equation in terms of t. When we are going to solve for t using the Sridharacharya formula, we get t equal to 5.4 or t equal to minus 3. Now time with negative value is not, it is not possible. So we'll only take t equal to 5.4. Now during this time, at this time the balloon, because it was already 81, but because the coin has taken 5.4 seconds to reach, by this time 5.4 seconds the balloon might have gone up, because it is going with the uniform velocity which is 12, the time is 5.4, so how much it has reached up or gone up? 64.8. So 81 plus 64.8 is the height of the balloon when the coin actually reaches or touches the ground. Relative velocity. What is the concept? If you take a different frame of reference, the velocity will be different. And we always see that a person which is sitting in the train, the speed of fly in the train along the direction of moving train appears to be less. Means if the train is going like this and the fly is also going like this, the speed is going to appear less. But if the train is moving like this and the fly is coming like this, then the speed becomes more. The stationary person on the ground, on the train, first of all, it will find it higher. Why this is lower and why this is higher? How this concept can be discussed? First of all, this concept or the this increment or decrement in the velocity, this decrement and this increment in the velocity is because of the concept we know as relative velocity. So what is the relative velocity? Please take into account A. This is the frame of reference which is associated with a person which is standing on the ground. So a person is standing in the ground. A is the frame of reference which is associated with the person who is standing on the ground. Now B is the frame of reference which is associated with the train moving with a uniform velocity. So this is A frame of reference, this is B frame of reference. Now both these reference frames are inertial frame of reference. We are talking about a fly. So let us denote the fly with some point P. Okay. So what will be XPA? XPA is the be the position of P with respect to origin A of frame A. Again XPB be the position of P with respect to origin O dash of frame of reference B at time t equal to 0. Let us see this with the diagram. What I am trying to suggest here is this is first frame of reference which is ground. This is second frame of reference which is your train. Now this is the fly. So what is this? XPA. This is P with respect to first frame of reference, XPA. And what is this? XPB. This is the velocity or position of let us take position of P with respect to this frame of reference which is B. So this is XPA, this is XPB. Let us take this as XBA. XBA is the position or positional difference of these two frame of reference. Okay. Now in this figure, please see that XPA is simply equal to XBA plus XPB. So what we have done is XPA equal to XPB plus XBA. Now differentiate it with respect to t. So just differentiate it, and we know that dx by dt is velocity only. So VPA is equal to VPB plus VBA, and let us rearrange it. VBA will be what? VPA minus VPB. So VPA is what here? Velocity of P means fly with respect to reference frame ground. And what is VPB? The velocity of P with respect to the reference frame which is train. And what is VBA? The velocity of reference frame B with respect to the reference frame A. So in this example, let us take VBA as say plus 10 meter per second. This is the velocity of a train. So a train is having a velocity with respect to the B with respect to A, which is the velocity of train with respect to the ground. And if you take VPB equal to 2, which is the velocity of fly. So train is moving say somewhere 10, and the velocity which is the relative one. See, this is all relative. This is all relative. This is 2. The velocity of fly with respect to the train. So if we take this equation, this one, the velocity of the fly will be what? VPA will be simply, VPA is what? VPA is simply VPB plus VBA, that is, we have taken this as 2, this as 10 and this as 2. So 10 plus 2, which is 12 meter per second. And the velocity is actually greater than, it was 12, but it is greater than the velocity of the train. Velocity of the train is 10, but we added 10 plus 2. So the fly velocity is added to the train and it becomes 12. Now assume that this train is going like this and the fly is going like this. So if the fly in the train flies in the opposite direction to the motion of the train, now we have to take this as minus 2 meter per second. So again, applying the same formula, it will be not 10 plus 2 but 10 plus minus 2, that is 10 minus 2. So now the speed decreases. The speed decreases. So when they are in the opposite direction, the speed has to be subtracted. And now if P is the frame of reference which is associated say with ground, and references A and B, they are associated with some two particles. We'll see in the equation and diagram also. The relative velocity of the particle B with respect to A will be what? I'm giving you an idea about this, right? We are talking about this relative motion. So our object is here A and B. Now they are moving, say A and B are moving together. So if A and B are moving together in the same direction, the things will be different. If they are moving in the opposite direction, the things will be different. So the relative velocity of particle B with respect to A, VBA, simply if we take it as ground, the velocity of ground means A with respect to ground, B with respect to ground. VBA will be VBG. We are just changing these A to G and B to G. So VBG minus VGA, that is VB minus VA. Okay. In the same way, the relative velocity of particle A with respect to B, VAB will be VAG minus VBG, which is actually equal to VA minus VB. See, this is VB minus VA. Here we have VA minus VB. So VAG and VBG are nothing but these two are AG and BG. These are nothing. These are nothing but the relative velocity. And what are the velocity of A with respect to ground, B with respect to ground? That is why, because they are relative to the ground, we are saying VA and VB simply. What is the relative displacement? We consider two particles, say A and B, which are moving along the x-axis, and with they have a uniform velocity, which is VA and VB. Now this is the distance XAO. XAO is the displacement from origin at time t equal to 0. This is also having a distance of XBO, means B means this particle, O is the origin. So distance is XB. What is the velocity VA? This is velocity VB. So what is the position when they are just starting, that is t equal to 0? Say some at t value, means they have started, and some t equal to t, it might have moved somewhere, and this also might have moved somewhere. So what is the position now? This is XA position, this is XB position, and what is the distance between these two? XB minus XA. So XA and XB are their position coordinate, and we can simply say that XA is nothing but, what is this XA? XA is simply XAO, means this distance, and the distance this A has travelled in time t. So VA into t, which is what? XA is the initial distance plus the distance it has travelled in time t, VA into t. Similarly, XB will also be equal to the initial distance from the origin plus the distance it has travelled, B has travelled in time t. And at time t, the displacement of particle B with respect to A will be what? We know that it will be XBA, so XB minus XA, sorry, XB minus A, like this. So XB minus XA, now subtract this from this, we get XBO minus XAO plus VB minus VAT. Here this is what? This is the displacement of a particle of B with respect to A, because at t equal to 0, initially we know that what was the difference. So VB minus VA, we know it as a VBA, that is the relative velocity of B with respect to A. Now when in this scenario, when VB minus, we'll take certain scenario, VB minus VA. Now when VA equal to VB, that means both have similar velocity, then this becomes 0 and we get only this equation. So XB minus XA is equal to XBO minus XAO, which means that the distance between two particles, if the velocity remains same, will remain equal to the initial distance at any instant of time, because they are moving with the same velocity. What happens? See, this is VA equal to VB, so this is moving with the same velocity, this is moving with the same velocity, so this distance will remain same everywhere. So the relative velocity of both the particle, because we started with this, and relative velocity will always be 0, VBA or VA equal to 0, because they are moving with the similar velocity. Now what happens when VA greater than VB, means A is moving faster than VB. Now if A is moving faster than B, then A is going to meet B somewhere at time t. This is what is happening. This is moving faster, this is moving slower. So at some point, because VA is greater than VB, they are going to meet somewhere. So at this instant, the relative displacement will be what? Because this is 0. At this point, at t equal to t. So thereafter the particle A will overtake it. At this, after t, it is going to overtake it. Now let us assume that VB is greater than VA. Now this velocity of B is greater than VA. Now, what happened? Because B has taken over. So VA, if it is going like this, VB is going like this, the distance will increase because this is faster. So both particles will increase with time, the distance between them. So they will never meet. When the driver of a Shatabdi Express running with the velocity V1 sights a goods train going ahead of him at a distance x in the same direction on the same track running with a velocity V2. Here it is being shown that V2 is less than V1. He applies brake. In order to avoid an accident, what should be the magnitude of the deceleration produced by the brakes? So the scenario here is, this is a track. When a driver of Shatabdi Express, say this one, running with velocity V1, sights a good train ahead of him at a distance say x on the same track. This is running with V2. But the velocity of V1 is greater than V2, so it is going to, if it doesn't stop, V1 doesn't stop, it is going to end with some mishap. So in order to avoid the accident, he has to apply, the Shatabdi driver has to apply certain brake. So what is the magnitude of this deceleration? Now this is the velocity of V1, this is the velocity of V2, and the velocity of Shatabdi Express relative to the good train is simply V1 minus V2, as we just suggested in the previous discussions. So if this relative velocity will become 0 in distance x, then only we can say the accident can be avoided. So what is the necessary deceleration? That is A. We'll use the equation of motion 2ax equal to v square minus v0 square, and this v0 square will be simply the relative velocity. This is 0, final velocity will be 0 because it is going to come, Shatabdi has to come at rest, and A has to be minus A because this is deceleration. When we rearrange this, we get A equal to v1 minus v2 whole square by 2x. Two cars A and B are at position 100 and 200 meter from the origin at t equal to 0. They start simultaneously with constant velocity this and this, respectively in the same direction. Calculate the time and position at which they will overtake one another. So what is given here is, first is A. So AO is 100. Then we have B, which is at 200. This is at 200. XBO is 200, XAOX is 100. Velocity of A is 10 meter per second. This is 10, and the velocity of B is 5. Now we know that this expression we have devised, XB minus XA is equal to XBO minus XAO plus VB minus VA. We know all these values. Let us put this with time t. Just assume that at t equal to t, they are going to overtake. When they are going to overtake, that means XB will be equal to XA. So XB minus XA will be 0. So let us put this value as 0. Other values remain the same. T will be equal to 20 seconds. Now let both car, they overtake at some x from XAO. Okay. So x equal to XAO plus VAT. It starts with 100, means initial position of x is 100, and in this time t, VA will move what? What is the distance? Speed equal to distance by time. So distance will be speed into time. So speed of A is VA, t is, we just found out to be 20. Let us add 100 with 10 into 20, that is 300 meters. The distance between Ahmedabad and Vadodara is 100 km. Two trains set off simultaneously from Ahmedabad and Vadodara towards each other. So Ahmedabad, Vadodara. One train starts like this, other train start like this. The speed of this train, one is 45, the other is 30. When will they cross each other? So speed of train which is set ahead of or say set off from Ahmedabad is VA 45 km per hour. Then the speed of train set off from Vadodara, means from here, if it is 45, we have to take this in the opposite direction as minus 30. XBO minus XAO, that is the train, they are in opposite direction. So what is the distance, which is 100 km? X of these two are 100 km. So when they are going to meet somewhere, the relative distance displacement, sorry, not distance, displacement, XB minus XA will be 0. So we'll use again this expression which we have found out from our discussion. xb minus xa is 0, xbo and xao we know the difference is 100, and we have used both these velocity with proper sign, and time will be 4/3 hours. What is frame of reference? This is a place or a situation from where an observer takes his observation, and this is called the frame of reference. What is the path length? The distance being traveled by a particle in some time interval, like this is the distance, and the change in the position of an object in some time interval is called displacement. So from here it starts, comes here, so this is the change in the position, this is called the displacement. If you add all these, it is the distance. So displacement is simply the final position, this is f, minus the initial position. The displacement can be positive, negative or 0, and the path length can be equal or greater than the displacement, but it cannot be less than. Average velocity and average speed, or the ratio of path length to the time taken for traveling it, is known as average speed. The ratio of displacement and time taken to travel is known as average velocity. The average velocity is given by delta x by delta t, which is displacement by time. Average speed is always positive, the direction is not important, it's a scalar quantity. Average velocity is in the direction of displacement, so it can be positive or it can be negative. It can be negative. And for a given time interval, the average speed can be equal, greater than the average velocity. Now, instantaneous velocity. If something is moving like this, we want to find out at this instance what is the velocity. For a given time interval, say from here to here, the average velocity does not give the information about how fast the object moves at different instance, like for example this instance, this instance. So by taking the limits, which is delta t tends to 0, very small time, the definition of average velocity becomes instantaneous velocity. So instantaneous velocity is delta x by delta t when this delta t limit tends to 0, and this becomes dx by dt. So the magnitude of instantaneous velocity is called the instantaneous speed. When a particle is moving in a straight line, it covers the same distance in the same time intervals, and its motion is called uniform motion. We have various graph, xt graph, vt graph, at graph. So xt graph, the slope in the xt graph, the slope of a line which is connecting the final position, initial position, that is x2 minus x1 by the magnitude of time interval, so t2 minus t1. So this is the slope, and this gives you the velocity at that instance. Average acceleration and instantaneous acceleration, if the change in the velocity of object is delta v in delta t time, so average acceleration will become delta v by delta t. What is the instantaneous acceleration at some point t, which is simply delta v by delta t, where delta t has to tend to 0. So this becomes dv by dt, or you can say you are double differentiating the distance. So d by dt of dx by dt, that is d2x by dt square. This is the acceleration. Acceleration is a vector quantity, and it is in the direction of change in velocity, and this SI unit is used as meter per second square. The slope of velocity, when we talk about VT graph, this is V, this is T. So the slope in the VT graph gives you the average acceleration of a given time interval. So the slope of the tangent which is drawn at some point, say if the graph is like this, the tangent is being drawn here, it gives you the acceleration at that instant. So if velocity and acceleration, they are in same direction, the speed of the particle is increasing. If they are in opposite direction, means opposite side magnitude, you can say, the sign, the speed is decreasing. This is known as the deacceleration of a particle. The area under which, like this, some area is there. So the area under VT graph for a given time interval is the displacement or total distance of the particle. For displacement, we'll take positive, negative. If this is the graph, this is plus, we have to take this as plus, this is negative for displacement. For distance, we have to take this as plus and this as plus, so we have to add these two. So that is what the total distance. Consider the negative area also as positive. There are certain kinematic equations for uniformly accelerated motion. V equal to V0 plus AT. So V equal to U plus AT. S equal to UT plus half AT square, and V square is equal to U square plus 2AS. These are the values, and in the chapter wise or the discussion wise, we use like this. The velocity of particle with respect to A is VBA, which is simply VB minus VA. The velocity of particle A with respect to B, which is VAB, is VA minus VB, and these two are opposite, so VBA is equal to minus VB. So this is about motion in a straight line. Thank you so much and take care of yourself.